Hi everyone, this is an example about composition of functions. So I'm giving you formulas for two functions, and I want to work on finding formulas for the composite function and domain of the composite function. Okay, of a couple different composite functions. Since we're going to talk about domain, let's go ahead and identify the domains of A and B here. Both are fractions, so we need to worry about dividing by 0. I don't have any roots in there at all, so I'm not worried about roots of negative numbers. So for function A, I just need to make sure 2x plus 1 is not equal to 0, which means 2x should not equal negative 1, and x should not equal negative 1/2. So here, I'm just going to keep track of it up above for when I look back later. For function B, I want to make sure that x minus 4, the denominator, never equals 0, which means x can't ever equal 4. Okay, so we'll use those later. The first composition I'm supposed to work on is an A of B of x. So if I want an A of B of x, that's going to be an A of 1 over x minus 4. So first, take your x, plug it into the inner function B, get your output. Your output is 1 over x minus 4. Next, take the 1 over x minus 4 and plug it into function A, and we're going to get 1 over x minus 4 in the top of the fraction, and 2 times 1 over x minus 4 plus 1 in the bottom of the fraction. So function A takes whatever you give it, builds a fraction with your input on top, 2 times your input plus 1 on the bottom. I think the first thing I'm going to do here is to deal with the parentheses. The big goal is to clear fractions in fractions, but I see people make mistakes with that. So I'm going to make sure everyone's really clear on the fact that that's a 2 over 1, which turns this into 1 over x minus 4 over 2 over x minus 4 plus 1. So the 2 only affects the numerator of that fraction. Clear fractions, the efficient way to do this is to spot the least common denominator for any of these inside fractions. So the x minus 4, the LCD is going to just be an x minus 4. And then we can take advantage of the fact that we have this big fraction bar, and we can multiply top and bottom by that to try and cancel out denominators. So we have A of B of x equal to, on the top, if we multiply an x minus 4 by a 1 over x minus 4, we just end up with x minus 4 divided by x minus 4, which is 1. So the top works out beautifully. The bottom, you do need to be a little bit careful. There's a distribute that happens. The first thing that happens is you distribute, and then you can work on a little bit of this simplification in your head. So if you multiply a 2 over x minus 4 by an x minus 4, you get some cancellation again. All that's left is a 2. If you multiply a 1 by x minus 4, you get an x minus 4, which means the simplified version of our function is a 1 over x minus 2. So that's simplified quite nicely. So long-term thing that happens to your x value if you first plug it into B and then plug it into A is that it gets a 2 subtracted from it, and it gets its reciprocal taken. So that's really all that the combination of A and B end up doing, even though it looks like a lot more happens. That's what it boils down to. Okay, separate this off. We're supposed to talk about the domain of A of B of x, so I'm just going to tack this on the end, but we might need some side work. Actually, I don't think we do. So looking at this, I can see that by the time A and B both work on the x value, it will have all of this happen to it, which means I'm in trouble if I started with an x of 2, because in the end I'll have a division by 0. So x cannot equal 2. That was actually the one that sounds at first when we're talking about domain like it's going to be the trickiest to find. 2 is the x value that gets me in trouble if I plug it into B and then take that output and plug it into A. So B doesn't have a problem with 2, but A has a problem with B of 2. The other thing that I need to be aware of is it doesn't make sense to plug an x value into the composite function A of B if it won't even make it through the first function B. So I also need to make sure that x does not equal 4, or I'm not even going to make it through function B. If this one seems at all like it's a little too magical to you, there is some work you can do to find this. Basically what we're saying is we need to restrict the domain so that nothing that gives B a domain problem is in the domain, and also so that no x values that make B of x not in the domain of A are included. That sounded really confusing. Let me think about if I can say that in a better way. So I need to exclude an x if it's not a valid input for B. I also need to exclude an x if it makes B of x not a valid input for A. So we're plugging B of x's into A, which means B of x's should never equal -1/2, right? If we want to plug a B of x into A will not accept it if it's -1/2. And you can actually build an equation out of this and solve. Let's see, I'm going to clear fractions, so I'm going to multiply by 2 times x minus 4. And I get a 2 on the left-hand side, and I get a negative x minus 4 on the right-hand side, which means I have 2, oh, and let's make sure this stays a not equal, should not equal negative x plus 4, which means -2 should not equal negative x, which means x shouldn't be 2. So we already found this. You don't have to do this work, but if it feels a little like you're just memorizing something that doesn't make sense to you, that's the way you could do some work to hopefully convince yourself that 2 is a bad idea. 4 is bad because you can't plug it into B. 2 is bad because you can't plug B of 2 into A. Okay, so we're going to go the other direction. This is a great time, if you think you're getting the hang of this, for you to pause and try and find B of A of x and its domain on your own, and then run through the rest of the video to check yourself. If I want a B of A of x, that means I should plug x into function A. I get back an x over 2x plus 1. I should then plug that into function B, so I get a 1 over x over 2x plus 1 minus 4. I would like to, let me move up now that I've used my equations. Clear fractions and fractions. Again, I don't have any weird parentheses here, so I'm just going to go for it. I need to multiply top and bottom of the big fraction by a 2x plus 1. So the top of the big fraction is just going to become a 2x plus 1, 1 times 2x plus 1. On the bottom, again, remember that the first thing that happens is a distribute. If I multiply this fraction by a 2x plus 1, the 2x plus 1's cancel, and I'm just left with the x in the numerator. I also have to multiply the -4 by a 2x plus 1. So I have x minus 8x minus 4 in the bottom, and I have a 2x plus 1 in the top, which means that B of A of x is equal to 2x plus 1 over -7x minus 4. Okay, once again, we want to be able to state the domain restrictions. So looking at this function, I can see that -7x minus 4 does not get to equal 0, or we'll have a domain problem, which means -7x can't equal 4, and x can't equal -4/7. So part of my domain restriction is x cannot equal -4/7. If I'm paying attention, I'll also recognize that I shouldn't be trying to plug an x in that's not a valid input for A, which means, if we go back up to the top here, x is not allowed to equal -1/2. I can't plug -1/2 into A, so I'm going to make sure I exclude that as well. Okay, so this is great. I don't need you to do anything else. But once again, just if you're a little baffled about why just looking at this final thing is working for us, there is another way to find that -4/7. So this is optional way to do it. What we're worried about is, are there any A of x's that we're not allowed to plug into B? So we want to make sure that A of x does not equal 4, because 4 is not in the domain of B. It's the one and only domain problem that B has. A of x was x over 2x plus 1. So if we want to make sure that that does not equal 4, we're trying to make sure that x does not equal 8x plus 4. Multiply both sides by 2x plus 1, which means negative 7x, subtracting 8x from both sides, should not equal 4, and x should not equal negative 4/7. So it gives you the exact same result. I just choose whatever makes sense to you. You should definitely recognize that there are two checks that happen when you're trying to find the domain of a composition. Okay, thanks for watching.